Hello, everyone. Welcome to my presentation on my 3D printed glasses case project for my Engineering and Architecture 3 class at Joliet Central High School. I am Osil Laram and I will be narrating you through my creative process throughout the project. Going through the first step of the engineering process, we begin by defining the problem. The problem in this scenario are the issues I had with my old glasses case. These issues are shape and size. My old glasses case was rather large and had a circular shape. Think of a waxing gibbous moon shape. These design flaws made my old glasses case very awkward to hold, hard to organize, and very hard to place anywhere considering its shape didn't fit neatly. So now that we identified the problem, I moved on to the research for the project. I researched glasses case design choices and why exactly glasses cases are made the way they are. I looked into the best materials used in specific situations. For example, you would typically want hard materials for their toughness that prevents the case from breaking if you were to drop it. Or you would want a case made from semi hard materials if you want a light and flexible case that is easy to carry around with you. I also researched size and shape. I found that the best cases are tailored specifically for the glasses they hold. If a case is too large, the glasses would bounce and move around in that case, which might cause damage to the lenses. And if a case is too small, the case frame would bend. So my design would have to be tailored to my specific glasses to make sure I avoid damaging it by making the case too small or too large. The final thing I researched was cushioning. The best types of cushioning that a case could have. I figured out the padded cases are the best ones. These cases protect the glasses from potential scratches. These cases are padded with foam pads or fabric linings. The second step of the engineering process is the generation of concepts. I proceed to create two possible different designs with different mechanisms. The design shown on top of the image of my engineering notebook is a triangular design. This design is very peculiar. This design is made up of two pieces, one on the inside, one on the outside, and would utilize a hook to open and close. And the two pieces will use like a magnetic force from the two magnets to remain closed. These magnets would hold the two pieces together, which would be the actual case itself and the protective shell, to make sure the case holding the glasses doesn't fall out while you're pouring them into places. The other design shown is in the bottom, and that would be a rectangular design. This design would be your more traditional glasses case design, and this design would utilize a hinge mechanism, which would be used to open and close from the middle. Both of these designs include fabric such as fillets and interior fabric lining for cushioning. The cases would also be printed out of carbon fiber PLA filament. The case design I would end up going with would be my triangular case design. Not only are triangles naturally just stronger shapes than rectangles are, but I also feel like this design was more creative, utilizing magnets and a hook opposed to the traditional hinges. After choosing the design I wanted to go along with, I began to design a cardboard prototype to give me an idea of what the shape would look like. I used Autodesk AutoCAD to begin the sides, and the faces. Then I used the drawing I made in AutoCAD and used the classroom laser cutter to cut out a piece of cardboard into the shape of the pieces I drew. I cut all the pieces and assembled them together with tape, but I only had but I made sure not to close the triangle incompletely to test to see if my glasses would fit. And as you can see in the picture on the bottom, the prototype was both too small and too short for my glasses. After the failure of my first prototype, I moved into designing the next prototype. This time, this prototype was to be 3D printed. As a base, I started off by modeling the case in Autodesk Inventor by using the size dimensions of the first cardboard prototype, before modifying them to be bigger. Soon after modeling the case, I modeled the shell that would cover the case. Though later on, right before I 3D printed these designs, I noticed how large these models were, so I scrapped the design and began on a new one. So the very next day, I started with fixing the case size and 3D printed the new case straight away. As you can see from the image on the right, the 3D printed prototype wasn't exactly a success. The model wasn't deep enough to fit my glasses, so my glasses would stick out like shown in the picture. But on the bright side, the prototype was long enough to fit my glasses, which solved the length issue that my first cardboard prototype faced. So for my next pair of prototypes, in order to save on material and time, I 3D printed bite-sized pieces of the actual model instead of the entire thing. What I did was cut off the majority of the case, leaving one of the faces and a little bit of the body sticking out. Another thing I did to save on material and time was to lower the filling filament to 1%, which means the pieces will basically be hollow while still being structurally integral for testing. I used this piece to test out my glasses case was deep enough to where my glasses could fit properly. Alongside it, I 3D printed a piece of the shell that would cover the case to see if the two pieces would be able to slide in together without any big issues, which did end up happening. And as you can see in the picture in the far right, you can see the prototype was a success. Both pieces slid in through each other perfectly, and the prototype passed my depth test. My glasses were able to fit comfortably inside the glasses piece. Now that I had everything in check and all the prototypes had given me all the necessary dimensions for my final product, I updated the dimensions and added the holes for the planned magnets. Right before 3D printing, I grabbed the models I made for both pieces and made an assembly in Inventor. This assembly was to check to see if all the pieces fit correctly without any issue as an extra precaution. After everything checked out, I began the 3D printing process. I set the 3D printer to use carbon fiber PLA plastic to print this draft of my design. Now, something that you can't see in the pictures is the hole for the magnet in the case shell. It's located in the very deep end of the piece that is sitting upright in the picture of the left. It would be very difficult to get the magnet inside the hole if I were to put it in once it was done 3D printing. So what I had to do in order to get the magnet inside the hole was to program a pause in 3D print. The pause would happen right before the hole was done printing, but before the walls began being printed, which left an easy access point to the hole and continued the print after I was done putting the magnet. Now, I wasn't able to do this myself. The print took longer than anticipated, and I had to go to my next class. So my teacher, Mr. West, had to insert the magnet for me in the shell for me. Thank you, Mr. West. The very next day, I took out the pieces of the 3D printer and removed the tree supports. I tried inserting the case magnet inside the hole in the back, but it just couldn't go in. The hole I made for the magnet was already super tight because of its small tolerance, but the tree residue present in the hole made it practically impossible for the magnet to go in. The picture on the bottom right shows you how the magnet sticks out, incapable of fitting inside the hole. No matter how hard I tried with pliers, I couldn't get the residue out of the hole. But aside from the magnet issue, the case worked perfectly as intended. So the shell was functioning as it was supposed to, so that meant that I could reuse it, and the only piece that had to be readjusted would be the case piece. So the only thing stopping me from having a functional glasses case was the diameter of the magnet hole in the back of the case piece. So what I did in order to get the correct diameter required for my case was to 3D print a bunch of small holes on little blocks with varying tolerances in the diameter to test out the best tolerance. After a couple of tests, I eventually found out the perfect diameter for my case, the diameter being zero point 0.6 inches, which you can see in the second to last block on the image on the bottom right. After fixing the diameter size of my model, it was time to 3D print my case piece one last time. The print was a success. The magnet sit right in snugly with little force required. The 3D print project was now mostly complete. Now, before I evaluate my design, let's give a quick overview of the design again to refresh your memory. My 3D printed glasses case is designed consistent of two triangular parts: the actual case itself and the protective shell. The case is supposed to slide inside the shell and stay inside thanks to both magnets sticking together due to the magnetic force. With a hook and handle present on the opposite face of the magnet hole, you're able to pull out the case from the shell with ease. The case was filleted in order to remove the possibility of the case stabbing anything such as notebooks or any other objects present around it. The interior of the case is meant to be lined with fabric in order to protect the case from scratches, and the entire case is made out of carbon fiber PLA plastic filament. While my glasses case was functional at the end of the day, it was nowhere near perfect. One small concern that I had is the magnet on the back case piece. I forgot to add in the super glue to stick the magnet inside the hole. This is the only concern that I have, that is human error in the construction process. I should have applied glue right before testing it to see if the magnet was capable of fitting inside the new hole. But this issue can be easily fixed if the magnet were to ever fall out. The next issue with my design is cushioning. Because the case was designed to be as tight as possible to avoid any potential bouncing, that means that I don't have a lot of interior space to work with. Because of this, I have a limited amount of options of fabric lining to use as my cushioning. Fabric lining might cause my glasses to stick out and not fit anymore. The only solution to this would be making the glasses cases larger in size. The last issue with the glasses case is the tree support residue. For some reason, during the printing of the new case piece, the top corner of the case piece spaghettied. Though, like the magnet issue, there's an easy fix with the use of sandpaper and melting the piece smooth with a lighter. Now that I have evaluated my solution, I am going to evaluate myself and how I handled the engineering process. During the making of presentation, I noticed that a lot of the issues I faced throughout the design of the glasses case was caused because of my lack of prototyping and testing. If I were to prototype more often, I would have spotted the magnet hole error a lot earlier and saved a lot of time and fulfillment. But I can't go back anymore, and the only thing I can do from now on is taking what I learned from this project and applying it to projects for the future. So from now on, I will be prototyping more often to avoid making the same mistakes that I made during this project. That was my presentation for my 3D printed glasses case project for my Engineering Architecture 3 class at Joliet Central High School. Thank you for your time.